The automotive industry has changed dramatically since Carl Benz produced his three-wheeled Motorwagen, the first road car to be powered by an internal combustion engine in the late 19th century. What we see on our roads today is the culmination of over 130 years of design and technological innovation. But even today, with over 4 generations of development, the automotive industry continues to evolve at a rapid pace. Throughout this programme, we'll be exploring the trends driving the changes in the automotive industry, whilst looking into what the future of transportation may actually look like. Exhibitions like this give manufacturers an opportunity to showcase their work to the rest of the world. And for the niche vehicle network funded project Aura, created by a consortium of 4 British businesses, it was no different as they unveiled the all-electric British sports car concept. Aura aims to reduce environmental impact through lightweight natural composites, low drag surface design and optimised location of battery cells, as well as cutting-edge in-cabin updates to eliminate that range anxiety and maximise real-world driver feedback.
Kunja has been one of the 4 partners involved in building the Aura concept vehicle. We're really excited for it to be the first car in the UK and probably one of the handful in the world to running Android Automotive OS. We've been building HMI systems in vehicles for coming up to a decade now, and it is one of the most interesting movements forward in the kind of frameworks and architectures that we use to build these systems.
So what exactly are the softwares and the hardwares that you've put into the car?
The hardware system that we've got in the vehicle is an NXP compute unit, an IMX system. And that is a single compute unit which runs both screens that we've got inside the vehicle. We've got a 10-inch touch screen which is on the centre console, and we've also got a 5-inch circular display, which is also again quite sort of novel in the way that we've implemented it. So a single compute unit that connects to the body systems, and then we surface that information through the Android Automotive OS, which goes up to our sort of high-level software, which is the applications and the UX UI that you see on the screen.
And what have been the most difficult things that you've had to overcome to get, from an engineering and technology point of view, to get the vehicle to where it is today?
This is kind of our first real deep dive into some of the hardware components. So we've certainly learned a lot from that aspect. Some of the lower level bits of software has been a big learning curve for some of our engineers. We've been working on the car for about a year, which is obviously a very, very tight timeline to develop a car from the ground up and put it all together into that finished product which you see here.
We came on and worked with Kunja as part of this project to enable customers to get into the vehicle and trust the range on board. So often you can get into an electric vehicle and the range can drop and dissipate and go all over the place. With our technology, it's giving confidence to the driver. And what we do with our system is we pull live data from the driver, the vehicle, atmospherics, weather and routing, and it means that you get a much more accurate representation of how far you can go, and you don't get that disparity between lots of changes in between journeys, and more trust.
So what we're saying there is that in the winter, for instance, an average car would actually have less range than perhaps it would in the summer because of the heat and the cold. But what your system's doing is actually taking that into account through sensors on the car.
We are indeed. So we're taking all those elements, we're making the prediction, and then we're using a machine learning algorithm to tailor the changes in the battery, the vehicle performance, and the driver efficiency.
So last year, the UK government announced plans to phase out the use of the internal combustion engine in new cars on UK roads by 2030. One alternative fuel that manufacturers are really exploring now is the use of hydrogen fuel cells. Hydrogen is the most abundant element on the planet. It's also the cleanest kind of fuel there is. However, it really hasn't taken off in the world of motoring yet. But with the sales of electric vehicles increasing, do hydrogen fuel cell cars have a future on our roads? I spoke with Ricardo's Joanna to see what the future may hold. Joanna, thanks for meeting us. Just explain to us the different types of uses of hydrogen in the automotive industry.
In the automotive industry, you basically can use hydrogen either burning it in the hydrogen engine or through a chemical reaction, you're putting it in hydrogen fuel cell, very often called PEM fuel cell. But all what it is several layers of really clever chemicals where the hydrogen comes in, hits the layers, the molecules split, the free electron gets released, and that's how the energy gets harvested. And then on the other side, as the molecules bubble through, they connect again, and all the byproduct is water.
What's the difference then between the hydrogen engine and the fuel cell?
The hydrogen engine actually really still burns the gas. Meanwhile, fuel cell just chemically splits the gas. So I think that's the major difference.
And are we seeing, is there a sort of lean towards one or the other, or is it 50-50 at the moment?
It's never a simple answer, is it? Within the hydrogen, we see also different OEMs going different ways. But very often, if we were to generalize, the smaller cars, we see tendency towards battery electrics. Then when you go to bigger sort of SUVs and start needing a little bit more energy, but people still very cautious that they have to have zero emission, they will go for the fuel cells, and we're starting to see them.
And in the future, how far into the future do you think it's going to be before someone like me is just driving a hydrogen car or a hydrogen fuel cell car?
Well, mass production is kind of already happening, because you already have thousands of Toyotas around the world. So as a consumer, if you want to, you can buy a hydrogen fuel cell car already today. So you probably buy one when you know that you have somewhere to refill it. So clearly, if you live somewhere in the mountains, you will have to wait a little longer for a station to be built there. But people in larger towns are starting to see good enough network that they can actually refill.
Now, I know you are massively behind hydrogen, but is there any downside to it?
I'm not the right person to ask. I'm sure there is a downside to everything, but for me, it is the most abundant element in the whole of universe. Surely somewhere in that is, why don't we just use what we have the most in a way that helps the planet for the future?
The growth in electric vehicles seems to be almost unstoppable. But if electric vehicles are going to become the norm, there's still a lot more that needs to be done. A significant number of drivers are still unsure about the practicalities of electric vehicles and haven't yet switched their petrol or diesel car for an electric one. Ricardo's Kenan and Michael gave us the rundown on what they are offering to help consumers make that switch.
So this is Ricardo's Connected. It's our latest technology demonstrator, and really it's about accelerating the rate of adoption of hybrid and electric vehicles. And to do that, we put some technologies which increase the efficiency, range, and also the appeal of the vehicle.
Brilliant. What sort of technologies have you added onto the vehicle then that's going to really help with those things?
Well, this vehicle uses our control software from our VIX, Vehicle Integrated Control System platform, and that allows us to put the latest hybrid controllers on it quickly. And then on top of that, we've added some connected controls which allow us to use data from the cloud. And on top of that, we've added our realistic augmented sound technology, and that allows us to put really nice but authentic sound augmentation in the car to make it sound really, really fun to drive, and also to protect pedestrians through external audio alerts as well.
So we've jumped into the car with Mike. Now, you're one of the engineers who've worked on the vehicle. Just explain to me, I mean, you can't really see a lot in here. Just explain what's going on then.
It starts here with the in-vehicle HMI. Ultimately, it's a posh sat-nav. Gives you the opportunity to be more efficient, but ultimately, you don't want to have range anxiety. You don't want to be worrying about, am I in the zone or not? So the vehicle will use the cloud data. It will back calculate how much charge it needs to cross that zone. As soon as you cross the boundary, it will drop into EV only, and then providing you're leaving the zone, it will pop out of it should you need to. If you still have charge, it will stay in electric only. As I said, it's ultimately there to be completely user friendly. It builds on our VIX platform. It's all completely integrated, and to the user, it does get over, like I said, range anxiety, which obviously is a certain problem.
Absolutely. Whilst the almost futuristic tech snazzy displays are winning over some, for others, it really is just glossing over some of the real concerns that customers are having over things like range anxiety. Research carried out by Ofgem shows that 38% of consumers are still worried about range, whilst 36% of consumers are worried about having nowhere to charge their car. Silver Power Systems are working to better understand what helps and what hinders the battery life of an electric vehicle. I was lucky enough to ride in the Watt Electric Vehicle Company's high-performance two-door electric coupe, inspired by the 1950s Porsche 356A. The sports car utilises Silver Power Systems' electric vehicle battery data management platform to help give vehicle manufacturers, owners and drivers powerful insights into battery performance and utilisation. It enables prediction of future battery degradation as well as the battery's remaining useful life. So Neil, fantastic prototype car. How did all this come about then?
About 10 years ago now, so in 2010, I actually did a little project that was called the LCAP project, Lightweight Chassis for Alternative Powertrains. And in that programme we designed a bonded aluminium monocoque that was capable of accepting either a combustion, hybrid or battery electric powertrain from a single primary structure, with a view that we would supply those to the manufacturers of specialist vehicles. And I built two of those, one with a combustion powertrain, one with a battery electric only powertrain. And in 2011 we took them around to see the specialist niche manufacturers, and we had absolutely zero interest in it whatsoever. Too early. So at the time, they didn't understand why you would want to be able to house different types of powertrain in your vehicles. And the feel was that the market had no demand for it, which at the time, to be fair, was probably right. Yeah. The real challenge for low volume companies in particular is that they don't have the in-house expertise or experience to develop a battery electric vehicle, and they don't have the financial resources to be able to go to a specialist and get them to do it on their behalf. Yeah. So around 2017, 2018, I started to think, well, maybe it's time actually we pull the dust sheets off of LCAP, we go back to that and look at what that would mean 8 years later, with all the changes in the supply chain that have gone on since and the maturity of the technologies that are now available. And we started work on a new version of that platform.
And engineering wise, you've had this journey from 2011 when that original idea with the chassis to now. What's been the real hard engineering things that you've had to overcome? Has there been specific things that you've just gone, why can't we just sort this bit out?
Weight is always the enemy, and obviously in an electric vehicle, when you start to then add up the challenges of performance requirement, range, you end up in this ever decreasing spiral where you need a larger battery to provide adequate range. You then need more powerful motors to keep the vehicle performance sensible, which need more energy, so you end up with a bigger battery and you end up disappearing down this awful wormhole really of just loss after loss after loss. So one of the key philosophies that we had setting out with this programme was to try and make sure that we designed a light electric vehicle platform, and the key driver for that for us was going cell to chassis with our battery tech. So we do not have a separate battery pack for the car. The battery is built into the primary structure of the vehicle, allows it to be very, very efficient, very good in both torsion and beam capability. It means that we have brilliant crash performance in all of the key areas, so front, offset front, side beam, side pole and rear impact.
And great fun, isn't it? It's just, the power is unreal. You put your foot down and it goes. Absolutely.
And I think the really interesting part of this is that the vehicle performs really well. It is a fast car, but due to the efficiency in the platform and the low vehicle weight that we're able to offer for an electric vehicle, we're doing that and providing that performance with very modest actual motor power.
Thank you, I'll get in. Lovely. Whoa, thank you. Right. So Pete, I've just come back from out on the track in one of the prototype cars, and the guys were really explaining to me how important it is your battery health and how to maximise the health of your battery. And you've got some amazing software that they've been using on the vehicle. So just explain what we're seeing here and what that's all about.
So there's actually two areas that we're helping in the vehicle development. The first of which is during the engineering development of the prototype vehicles. We're enabling them to understand exactly how the battery is performing and the factors that are affecting its performance. So the way it's been environmentally exposed within the vehicle, the currents and things which it's been subjected to when the vehicle's being driven. Now, once the vehicle goes to a customer, we're very much more focused on the lifetime performance of the vehicle and optimising the battery's performance over its lifetime, minimising the degradation that the battery suffers and allowing the user to get the maximum performance from the vehicle. And when batteries degrade, although there's many complex mechanisms for degradation, they result in really two primary observable effects, one of which is a loss of power delivery and the other which is a loss of energy, so a reduction in the range of the vehicle over time. So providing visibility of that allows us to both optimize it electronically through the software in the vehicle itself, but also allow the user to understand how their behaviour also impacts the battery performance over its lifetime.
And so what we're seeing here is some of the data you're collecting from the car, as it were, is it?
Yes, so within the vehicle, we have a small IoT device that's basically collecting data directly from the vehicle's control systems, and that's not just the battery, but it's also the powertrain controller, which is controlling the motor within the vehicle. So we can see the requests being made by the driver, the way the powertrain's performing, and the performance of the battery. So we're looking at things like energy throughput, the amount of energy that's being charged and discharged through the battery, the temperatures it's being exposed to, and the currents it's being exposed to, because that obviously causes self-heating deep within the battery itself. The actual electrochemistry within the cell responds over quite a long time constant. So if you're thinking you're doing a 0 to 60 dash within your sports car, you can exceed the normal operating parameters of that cell for a short period of time without any detrimental effects. And so by having very accurate models of the cells, you can understand where you are in that performance envelope. So you're still operating the battery in a safe condition, but for a short period you can get increased performance from it.
So it's like the sprinter just pushing that bit harder for that bit and then not pulling the muscle, as it were.
Yeah. You can only do that if you've got detailed instrumentation of the pack and the models support that, so you know what's happening to the electrochemistry within the cell.
So what you're doing here is really maximising the lifespan of that same pack. So if you didn't have this, your batteries might last less time than the same batteries in a vehicle with this.
True. And back in the vehicle development phase, is have we got one cell, for instance, that's not been cooled as effectively as the others? Is there one that's been exposed to, within a parallel system, higher currents than one of the others, for example? And if we can equalise all of those, it's that equalisation that will also extend the pack life.
Whilst car manufacturers are making positive steps in the right direction to make their vehicles cleaner, there's still an audience out there that believe that there should be some better options for vehicles in cities. And one company looking to make a real impact in this area is Zemo Vehicles. Marianne, you've let me sit in your prototype vehicle. Just explain to me a bit about it.
Zemo Voxy, it's a taxi for city trans. It's a taxi, so a driver sits here, you hop in there, which is easy to pick people up. It's going to be electric pedal assist at first, so we can go in cycle lanes. It will later then be a pure EV and a road vehicle, and then it will be autonomous, and then a four-seater autonomous is the road plan.
And it's amazing because it's got space for luggage, hasn't it? It's got space for luggage underneath.
Yeah, large suitcase in the boot, 2 flight cases underneath, all in the footprint of a bicycle.
I know, it's phenomenal. And what sort of range can you get out of something like this?
So you can get 100 miles on the battery alone.
100 miles on the battery?
Yeah, that's at night time, and with the solar roof, that's going to be 140 miles altogether.
Wow, and then you've got the pedal assist as well if you wanted to keep fit.
Yeah.
And now this is your business. You're the chief executive of this business. How long have you been in sort of R&D, and how long does it take you to get from idea to this point?
We started the working prototype project in 2018, but they had the idea originally in 2011.
Wow.
Yes, but I put it on hold for a good number of years, from 2012 to 2018, because the battery technology and the solar technology would have meant it was just a commuter vehicle. But now the range you can get out of this it makes it be able to replace all-day use service vehicles.
In terms of the next stage then, you've got it to this point now. When do you think it's going to be available? Actually, when will we see it in London?
Well, I'm looking for a buyer, someone to buy a fleet of them for between 100 and 300 vehicles. That will get us to batch production. We'll be doing our durability testing in those environments, and then our plan is a taxi for London. So we'll start as a pilot scheme in the Olympic Park, and then move to Waterloo, St Pancras, and then expand from there to the whole of London.
Whilst global disruption, changing consumer behaviours and advances in technology are changing the automotive industry in many ways, the traditional business model of designing, manufacturing, selling, servicing and financing vehicles remains. Yet at the same time, the automotive industry is rapidly moving towards a new era, driven by sustainability and the shift in changing consumer behaviour. encompassing electric vehicles, mobility fleet sharing, onboard sensors, new business models, and connected and autonomous cars. What will the future of mobility look like in the real world? Well, as we've seen here today, there's so much collaboration and innovation in this space already, but it's clear that automotive companies will need to continue to innovate and develop solutions in a much more agile way in order to react quickly to changing customer demands and market opportunities.